what's up, everyone? It's your boy, John. O H H A back. I H I M. We're back. We're back with the lab protocols, with the lab journals, with the lab, with the general chemistry labs. Yeah. Oh yeah. So what was I doing? Yesterday I was writing till what? Oh yeah, I remember now. It was I had to write but the calculation part with the theoretical yield in type sheet. So starting material, suppose the mixture contains the water soluble salt like calcium nitrate. So okay. Reaction for identification slash collection. You add the potassium permanganate, calcium ions react with carbonate ions, so we get the calcium carbonate. Insoluble precipitates out. Why is this the yield? The experiment can only isolate something that comes out as solid. The original salt is salt, so you can't just weigh it. What can you weigh it? Is the precipitate. So when we calculate the theoretical yield, we convert it from the moles of the metal ion in the original salt to the masses of the carbonate that will form. We will convert from the moles of metal ion. It's research on for 30 minutes. Wait. We convert from the moles of the metal ion in the original salt to the mass of the carbonate that will form. Each cation metal is 1:1 with, okay, so that's a good thing that it's 1:1 to form 1 mole of metal carbonate. The precipitate mass reflects the amount of metal cation in the original mixture. So can you do this calculation with an example? Like initial amount of, I don't know, the 37.5 percentage of 5 grams, and just make up a value as yield, and show me how you connect the initial and final. Let me see what GPT is doing. Maybe it's mentioned here. Oh yeah, it should be. Absorption, liquid extraction. The basis of all extraction procedures described in Nernst distribution law. The substance distributes itself between two immiscible solvents such as the ratio of concentration. Wait, okay. Start with the mixture total. Oh man. Oh man. Edit. Beep, 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 beep. No, daily. Daily type sheet. Fa. Fa. Change. Switch. Oh, come on. 107? What? She. So total mixture, we got the fraction 1.87 grams of, let's say, what was it? Calcium nitrate. Now, what is the formula for calcium nitrate tetrahydrate? Copy. So, was it? It's CaNO3 twice dot 4H2O. That's that's when it's in water, or it needs water to be like that. I'm gonna ask some more. So, does the water part always with it, or when I dry this sample, or the ones we get when we buy them, does that also having this tetrahydrate? So the mixture contains 1.875 grams of one of the soluble salts, calcium nitrate tetrahydrate. Convert salt mass to moles of metal ion. So we got the divided by molar mass. So each formula unit contains one Ca2 plus. So number of moles of Ca2 plus is going to be this. Okay. Use the 1:1 mole ratio. So whatever, however, calcium. Somebody's up there. What's up? Sans fan. Appreciate you for checking out the stream. Fun fact, I'm gonna be having my labs in about 3 hours. It's gonna be crazy. Okay, so it's 1:1 ratio, so convert the moles of carbonate to mass. We get 1.14 grams of carbonate. We should get 1.14 grams of carbonate. So it was 1.87. Okay, okay. Now my question on the
Found out how to get free Pokemon.
what? Found out how to get a free Pokemon.
To show you what's up, colon D.
I apologize for the slow messages, but okay. The Sans fan, you found how to get a free Pokemon. How did you which game are you talking about? Is it the Pal World or is it Pokemon Go? Dalmatians was so this is a great question. Stop glazing me, AI. Stop glazing.
Multiple free ones. Roam hack.
Multiple free ones. Rome hack. Oh shit. Which game are you talking about? Which Pokemon game? So so my question was this thing, the tetrahydrate. Is it always the part of calcium nitrate? Uh oh, come on. Where's the question I asked? Why? What you usually buy? You almost getting the tetrahydrate form. The tetra part means 4 molecules of water are water.
Look up Visual Boy Advanced Roam hacks.
Look up Visual Boy Advanced ROM hacks. I'll look it up. Where should I look it up? YouTube? Also, make sure when you do these ROM hacks, just be careful because I heard that these fucking companies they don't want you to do it. Duh.
Google.
And
All legal.
oh, okay, interesting. Mm-hmm. A lot of Pokemons.
Look in Discord.
Unfortunately, I'm not a Google all legal. Okay. Look in Discord. What's up,
See
Dalmatians?
any new changes. Also,
Could make me my.
make me Maduck and lol.
I could see any changes. Yeah, I did see the religion one. Is it good? Is it? It's okay. I mean, it's not harmful in any way. But yeah, maybe you could have had Hindu, which is another religion. I guess I don't know. And I want you want to be no. I could make you the mod maybe. Are you just mod right now? Oh, there's a moderator type. What's your stance now? Okay. I think I'm mod right now. That's good. Yeah. So what was I doing? This means 4 chemicals of water are chemically trapped inside the crystal lattice of the salt. This looks like this. The look. It looks dry, white crystals of granules, even though it contains water. Okay, so the tetrahydrate is gonna be there even if it's dry. Okay, Sans fan. This is interesting. The whole there's a lot of Pokemons. I'm not a big Pokemon guy. I know very few Pokemons. I know Charizard. I know Mewtwo. I know Dragonite. Oh, I forgot what's the name of this one. I forgot. Interesting.
Dragon, it's a W.
Dragonite. When I saw this thing, I was like, oh, that looks cool. I know some basic Pokemons. The Geodude, or is it called Geodude? Squirtle. Squirtle. There's a ghost one. I forgot the name of that. There's of course Geodude. Okay, that's Geodude. There's of course this thing. Pikachu. Of course. Of course.
Mudkip, Dengar.
Dengar. Mudkip. Mudkip. I don't think it's Mudkip. Because I feel like that's not Mudkip. The name of the ghost. It's a purple one. Yeah, there's Mudkip. Okay. I haven't seen that one. Dengar. No, Dengar is something else, bro.
Asterisk.
Gengar, okay. Okay, I should. Yeah, that's the one. Gengar, yeah. I thought it was some different name. But yeah. Okay. Focus. So the ratio of calcium ion is going to be same when it's in nitrate or carbonate. The same goes for magnesium, zinc, strontium, I believe. So so from this, I'm guessing any of these are forming 1:1 ratio with the carbonate. So the initial number of moles of the metal cation should be the same with the number of moles of carbonate theoretically. Exactly, all four possible divalent metal ions. Okay. Now in the case of insoluble compound, now in the case of insoluble compound what, is there any sort of formation or change, or is it gonna precipitate just like this form? Let me get some water. If I leave here tomorrow. Nothing's new is formed. Okay. How about I'm guessing this one is also like I'm guessing this one is also like the same because we convert them to salt and then revert them back to the acid. Enter. I pressed enter. God damn it. God damn it. This one is different from the carbonate case, but it ends up as being original compound. Okay. Hints for precipitating a dissolved sample. Drop your precipitant slowly into the solution if the local concentration of your precipitated salt is high enough. Slight streaks are observable, which vanish after gentle shake. The precipitate will remain when the all-over concentration exceeds the solubility product. If your precipitation is complete, let the solution settle down. Test if no more further precipitation if adding 1 drop or more precipitant. No streaks should be visible. Keep your solvent until the end of your experiment. When separation your product via vacuum filtration, first wash the formed crystals carefully inside the filter crucible, then apply the vacuum. The washing is more effective like this. What? When separation your product via vacuum filtration, first wash the formed crystal carefully inside the first filter crucible. Then what do you even mean for separating the crystals? You're already applying vacuum. What do you mean? Is my English too bad to understand what they mean, or is there a real flaw? 107 subscribers. That's cool. RCOH plus NaOH gives RCO. Yay. You will measure the density of your dried water insoluble sample. For this, find further information on section 10. There are several different solid, liquid, and liquid-liquid extractors which work either continuously or discontinuously. An example of an apparatus used for discontinuous solid liquid extraction is a sock sled extractor, which will not be topic of this course. Okay, it was just an example. Nope. Okay. Now, can I again get the calculation part once more and also explain this part with the insoluble precipitant separated, that the number of moles of the metal cation is gonna stay the same before and after. Even though the I forgot the common name for the other part that is attached to the metal here, carbonate or nitrate, etc. According to Nernst distribution law of multiple extraction, repeating an extraction several times with a smaller amount of solvent will later lead to better separation compared to the normal, right? Than a single extraction with a bigger volume. Extraction of iodine from aqueous solution with organic solvent dichloromethane, which is de facto insoluble in water. Non-polar iodine is much better. Okay, so what? So N0, an initial number of substance. It's just proof, right? I don't think it doesn't have anything to do with my part. I don't think so. Oh, come on.
What was the package you got?
What was the package you got? Which package? What are you saying? So,
From
Anion.
David.
From the video. Oh, okay. I could show you now. Look at these. Oh, that's amazing. Yeah. It's a case for my tablet, which is pretty cool. Yeah. That's what I mainly got. Then these wired earbuds, I guess. Oh fuck. It's not even working. Okay, there we go. Total mixture mass. Is it 5 grams? No. I don't think it's mentioned how many we are getting. Yeah, it's not mentioned how much we're gonna get. Water soluble fraction 37%. Why are we talking about only the water soluble? Okay.
Cool.
Cool. Yeah. I mean, one of the main uses for that would be I don't have to bring my laptop to university every single time. I could just bring the tablet. Otherwise, I have to bring both the tablet and the laptop, which is not useful. So yeah. Could you do part of insoluble and insoluble and the inorganic one? Then I'll show them. I'll write more on the aqueous solution part. Come on. I'm still not writing it. Still researching. Can you even call this researching? So I just saw your question. Isn't Buddhism equals Hindu? Okay, there we go. What sort of ads though? Mid-journey creation. What is this? Is it an ad? Assume. Can I do the assumptions? I'm not sure. Insoluble fraction 25%. One example, experimental mass. Where did you get this 1.18? So, the calculation part, 10%. Okay. Mm-hmm. Okay, instead of assuming the mass of the mixed compound being 5 grams less, just say it's m theoret m initial. Let's just keep as variables. Initial total mass of the mixture, 0.15 initial experimental mass, exp yield equals m soluble experimental by 100. No stoichiometry required because the compound remains chemically unchanged. I'm guessing that's the way. Dude, this yield calculations. Insoluble fraction 25 WT percentage. Total mass of the mixture. Insoluble theoretical equals insoluble theoretical. I have to write the whole thing. 0.25 times mi experimental mass MEXP insoluble equals realistic value after the errors, etc. Yield insoluble. Theoretical insoluble into 100. That would be the value. No stoichiometry required because the compound remains chemically unchanged. No stoichiometry symmetry required because the compound remains unchanged. Chemically unchanged. Now, water soluble. So theoretical mass of the original salt is 0. Yeah. Now let moles of metal ion. Number of moles. Molar mass of the metal salt. Okay, so we calculate the number of moles. Water soluble metal salt. 37.5 WT percentage. MAQ theoretical equals 0.375 times M initial then we calculate the molar mass of the metal salt. So we have to figure out which sort of salt did we get? What is the water, or at least which metal ion is involved? Because only with that we could figure out the molar mass. We have to figure out which M2 plus was separated. We got a sample. Moles of metal ion. Number of now we got finally found the number of moles. Number of moles. Theoretical, right? Metal cation. Each salt contains one metal cation. Is that true though? Each salt containing one metal cation. Magnesium, silicon, copper. Wait. Calcium, magnesium, zinc, strontium. I'm guessing, yeah. And M2 plus, right? Yeah. Equals 0.375 M initial divided by M salt. AQ salt, right? AQ. 1:1 precipitation reaction. M2 plus 2 CO2 CO3 2 minus MCO3. The precipitate that we get with M2 plus. So therefore, number of moles of MCO3 equal to number of moles of M2 plus. Only the number of moles remain the same, not the actual mass. Theoretical mass of carbonate. Molar mass of the carbonate MCO3 so initial mass divided by the molar mass of the salt times molar mass of the carbonate. Why? What is that? What is that calculation though? Could you explain this part a bit more? More, not It's gone. It's gone. Convert moles of carbonate back to grams. To get the mass from moles, you multiply by the molar mass. Number of moles of carbonate times molar mass of carbonate. Now substitute the expression for moles. Convert that salt into moles. Because the reaction is 1:1, these moles remain the same number of moles of carbonate. Convert those moles into grams of carbonate. Wait, why is the... Wait. But here we are not including the experimental mass of the metal carbonate, because of course, you are not gonna get the exact number of moles. Some are gonna be lost. Just a minute. Of course, you fucking piece of shit. So yield percentage equals number of moles of wait, no. So we calculate the theoretical carbonate. Okay. So the molar mass of carbonate divided by molar mass of salt. What does that molar mass of the metal carbonate by molar mass of the salt into what does that get you though? Just a bit confused here where you divide the molar mass of the metal carbonate with the molar mass of the metal salt and multiplying it with the initial theoretical mass. Suppose your instrument convert mass of the salt to moles of the metal cation. Yeah. This gives moles of the metal because 1 mole of salt contains 1 mole of metal. Yeah. Convert moles of the metal cation to moles of carbonate. It's not readable. Mm, moles of, yeah, that's correct. So more mass of the theoretical is moles of carbonate. Okay. Substituting moles of, yeah. So more mass of the theoretical equals mass of salt by molar mass of salt times molar mass. Okay. Okay, I see it. I see it. I see it. So what you do? We got the number of moles. So conversion of conversion of mass of the metal salt to mass of the mass of metal carbonate. Theoretical. So M is equal to 0.375 M initial times molar mass of CO3 divided by M of salt. This formula is the number of moles of M2 plus and number of moles of MCO3. Experimental mass. MCO3 experimental. The mass of the separated AQPPT in lab. will the percentage equals, yeah, by theoretical CO3 times 100. Fuck. Okay, that's that. Now it's for organic, okay. Now, or I'll just. Why do I have to keep it writing? It's just like the insoluble acid is converted into sodium salt and then regenerated. So I'm guessing not a lot of is lost, right? Organic acid fraction 37.5. Organic theoretical, yeah. Ah, fuck, that's not what it is. It's 0.375 times M. Now, acid, organic, organic acid. Is converted to sodium salt, then again regenerated using acid. Therefore, final product original acid. I hate that I have this space. What can I do? I could do some math up there. Yeah. Yield. Uh, experimental. From that. MEXP. MEXP. That was stupid. Now. Yield. Insoluble aqueous. MEXP organic by theoretical organic times 100. No stoichiometric corrections needed. Okay. What else? I'm guessing that's basically it. Do we got more? Looks like we got more. We got now it's experimental. Hmm. I'm getting a call. Just a minute, YouTube. What's up? Okay. Your average Sans fan. I got an Undertale. I really apologize. I don't think I could do Undertale right now. Because I need to write the lab stuff. Let me see if I could. Okay. Go. Fast. Because this is not looking good. This is not looking good for me. What do you mean? Some bad stuff. I just heard that I have to do the whole section 10. Oh man, I need to check if it's true or this guy just fucking blah 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 blah. Mm-hmm. More information. Okay. If I have to experiments. Oh fuck. Fuck. Okay, do prepare. Okay. To sell 1.5 grams of glycine in 25 milliliter water, it may be necessary to heat it carefully in a hot water bath. Dissolve 2 grams of copper acetate. Both cis and trans copper glycinate are synthesis and isolated from water soluble copper and salt glycine. Both cis and trans copper glycinate are synthesized and isolated from water soluble copper to salt and glycine. To sell 1.5 grams of glycine in 25 milliliter water, it might be necessary to heat it carefully in hot water bath. Dissolve 2 grams of copper to acetate monohydrate in 25 milliliter waters. And heat it up to 65 degrees Celsius, 60 to 75 degree hot water bath until everything is dissolved. Heat 25 milliliters ethanol to 65 and pour it onto the copper to solution. Both solutions should be, make sure the glycine solution is 65. During the addition of glycine solution, let the solution cool down to room temperature and then put it to an ice bath for 15 minutes. The formed crystals are isolated via suction, filtration, and weight. The filtrate is kept in the beaker you need for the next step. Synthesis of transfer 1.5 grams of copper from the crystals from the first step, and 1 gram of glycine into a round bottom flask. Add 10 milliliters of filtrate from the first step and zeolites. Build a recrystallization apparatus and heat the mixture for an hour. The mixture should be slightly boiled. Adjusting heat rate accordingly. If necessary, leave a small gap between the heating mantle and the flask to reduce heating power, and solid should not dissolve completely. After 1 hour, remove the heating and filter your hot solution via suction filtration. Put your filtered crucible into the oven for a few minutes directly before the filtration. Drying your products. Dry both your products in a desiccator and determine mass of the dried products. Can I do section 2 and 1 the same day? One, two, three. Can I get work on this, but just only the main dissolve 1.5 grams of glycine. 25 milliliter water. It might be necessary to heat it carefully after in a hot water bath. Section 2. Section 2. Preparative synthesis. One 1.5 grams glycine. 2 grams acetate, copper to acetate, monohydrate. Until everything is dissolved, heat 25 milliliters of ethanol. Pour slowly together. Hot bath. (60 degrees to 70 degrees Celsius). Cooled. Ice bath. Crystal formation. Vacuum filtration. Suction filtration, vacuum filtration. Separated crystals. filtrate. $1.5 crystal plus 1 grams of glycine, round recrystallization apparatus. Solid should not fully after 1 hour. Remove the heating and filter your hot solution via suction filtration. Put your filter crucible over the oven. Remaining crystals. Cis crystals. Trans crystals. Filter via suction, filtration. Heat the crucible. Oh fuck. So that's the workflow. One, two. Interesting. I'm seeing some folds. looks pretty easy. It's gonna take some time with the heating and cooling. Oh fuck. $51. Wait. $55. 56. 60. 61. 63. 67. 68. 69. 69. 70. 72. 73. 76. 77. 78. 79. 80. 81. 82. 83. Section 1. Section 2 starts at 49. Exactly, conceptual straightforward. It's just about mixing the right solution. So, do you think it's a better idea to do section 1, 2 on the same day? mostly about dissolving, separating, precipitating, filtering, and drying of solids in the desiccator can be left overnight. Section 2 requires heating, cooling, and recrystallization, which all can be done with the same day. While the desiccator is running, you can start section 2 because mm-hmm. Yeast has performed fermentation has separated the product by distillation, and a solution of ordinary sucrose is fermented by ordinary dry yeast. Put a fermentation lock into a pierced rubber plug. Put the fermentation lock into a pierced rubber plug. Put 35 grams of sucrose into a Pyrex bottle. Dissolve it in 250 milliliters of 2:1 mixture of cold and hot tap water. Add to what is this step? For assigning groups, there are a few things to consider. Your 1D, then it's on 13th. Place number 219. So the fume hood, yeah. 4. Today's 2, 3, 4. Okay. Participating in production during fermentation. Fermentation log is a small tube, a U-shaped tube, partially filled with lime water. When yeast ferments sucrose, it produces ethanol and CO2. Okay. So section 2, I wrote the basic stuff like the put 35 grams of sucrose into a Pyrex bottle, dissolve it in 250 milliliters of 2:1 mixture of cold and hot tap water. Add 2 to 2.5 grams of dry yeast. Note the exact weight and close the bottle with the rubber plug and fermentation lock. I don't get this thing, fermentation lock. Where is it? Working place? Where is the fermentation lock? I did not see that. Centrifuge tube. Quick fit. Porcelain plate with pits. Where's the fermentation lock? I don't see it. It's grease, right? Syringe with grease. Distillation bridge. Lady condenser. No way, I decide. Snap-on cap bottle. Pierce rubber plug. I think that's the one, right? Yeah, fermentation lock. Pierce rubber plug and fill in with lime water. Wait. So to get the lime water, we are dealing with lime, or is it CaCO3? Calcium hydroxide. Okay, so how do I there calculations involved? Yeah, there is calculations. So. Put the fermentation lock in a pierced rubber plug. What's a rubber plug? Come on. Mm-hmm. Okay, we got the pierced rubber plug. Okay, that's good. Put 35 grams of sucrose into the Pyrex bottle. Dissolve it in 150 milliliters of 2:1 mixture of cold and hot tap water. Add 2 to 2.5 grams of dry yeast. Know the exact weight and close the bottle with a rubber plug and fermentation lock. Put it in the back of your place. Put into the back of your place in the fume hood and let it react for 1 week. 1 week? I'll change my dress in a bit. Oh, I'm so fucked up, bro. Gang, I'm so fucked up. I just realized that I should have an overview of all the experiments. I just have an overview of the first one. Stupid. 1 week, okay. Have a look at the suspension and the lime water and the fermentation log directly after you start it, after 2 hours, and the beginning of your next working day before you filter it. After approximately a week, minimum 5 days, filtrate the suspension and put the filtrate into a round bottom flask. Okay, before, let me see my timetable. So the first day, 6 days. Okay, I got a 1 week gap. I'll do section 1 and 3. After approximately a week, filtrate the suspension and put the filtrate into a round bottom flask. Filtrate the suspension. How do you filtrate? Put a cut out a full circle out of a filter paper that fits exactly into, then prevents decant the filtration before filtering. At least it saves a lot of time. Make sure not to shake it before decanting. If you do a vacuum filtration and your crucible gets blocked, it works rather slow. Transfer the filtrate into another container from time to time.
WSP.
Yo, guess 1337. How's it going? Oh man, I'm so fucked up. I should have all the experiments, an overview of all the experiments on my journal, and I just did one. I got 10. It's not looking good. So, I'm gonna do the fermentation too on the first day. The product of fermentation is separated via distillation. Build up the distillation apparatus and filtrate together with 3 to 4 pieces of zeolites into the distillation flask. Start the distillation and note the temperature every minute. Distill until you're sure the whole product is distilled over, but make sure that it's less than 100 milliliters. Filtrate together with 3 to 4 into the distillation flask. Start the distillation. Wait.
The server is much more expanded. Bro, good job. Got the same LPCZM12. I just picked the minor one, the closest to my age in the age rolls lol.
Okay, the server is much more expanded, bro. Are you talking about in general? What do you mean, dog? Whew. Okay, so build up the distillation apparatus. Filtrate together with 3 to 4 zeolites. Okay, product forms. The product forms a positive azeotrope with water. Crackcord. Oh, okay, yeah. I just picked the minor one closest to my age in the age. Oh, there's an age roll. Oh, yeah. Hmm. That is kind. It's gonna be weird in the subreddit, like the age gap thing. More when more and more people comes in, that's gonna be weird. But let me just complete this. First, the azeotropic mixture. What? Will distill over until some point at the temperature start to increase, indicating the majority of the product has been distilled. However, in order to get all the quality, get it as quantitatively as possible, keep distilling until the temperature is 100 degrees Celsius and you have collected 80 to 90 milliliter of the distillate. For the next part, it's important that you don't exceed 100 milliliters. In case you have distilled more than 100 milliliters, ask your supervisor for instruction for the following step and be prepared for more complicated calculation. You can also label the receiver flask with example an 80 milliliter mark. Okay. The concentration of the solution is determined by measuring its density. Fill the distillate from part 2 quantitatively into a 100 milliliter volumetric flask. Flush the flask and the funnel with distilled water and fill the volumetric flask with distilled water until the mark. Then perform a density measurement using cyanometer. Additionally, measure the alcohol content with the hydrometer. Fill 60 milliliters of your solution into a graduated cylinder. Ask the supervisor for the hydrometer. Oh. What's next? Acids and bases. Okay. Okay. No. Okay, now. Can I get an overview of the section 3 experiment? I did not even get the spelling correctly for. What's next? Acids and bases preparation of solution. Each student knows how to prepare an exact solution by dilution of a more concentrated solution and weighing of a solid sample. Exact solution by dilution. Each student knows how to prepare an exact solution by dilution of a more concentrated solution and weighing of a solid sample. Two solutions are prepared, one by weighing in the solute, the other one by dilution of a more concentrated solution. Preliminary work. All students have to calculate all the masses and volumes that are required for the preparation of all the solutions. Supervisors might ask questions. And exactly 0.1 mole of iron 3 solution have. Oh, this is the one that I got. I have the where is it? This thing for the sample lab journal. They had section 4, and looks like section 4 has synthesis of Schiff's base. Is that involved here? I don't know. Fermentation setup. Dissolve 35 grams 2 to 2.5 grams of dry yeast. Insert a rubber plug into it. Fermentation log containing 5 milliliters of lime water to allow CO2 to escape and prevent contamination. Let the mixture ferment for 1 week in fume hood. Monitor periodically for CO2 protection and suspension changes. Separation of yeast. After fermentation, filter the suspension to remove yeast. Collect the filtrate for distillation. Build the distillation setup. Yeah, of course. After fermentation, filter the suspension to remove the yeast. Now, filtration part, that's where you have, if you are using vacuum filtration, then you have to do some extra stuff. And exactly 0.1 moles of iron 3 solution have to be prepared from iron 3 chloride hexahydrate. Then an exactly 0.004 molal iron 3 solution has to be prepared by dilution of 0.1 molal solution. Okay, and exactly solution have to be prepared from iron 3 chloride hexahydrate. How do you prepare that? So I'm guessing the iron 3 chloride hexahydrate is solid. So if we're going this is 0.1 gram per 0.1 gram per milliliters, right? 1 molal is gram per liter. or zero point 0.1 molal per liter. That's a really small concentration. Determination of the pH value. Each student knows how to determine a pH value of the solution using indicator paper. Litmus paper, right? Yeah. I mean, the workflow for this. Start sucrose plus water, cold, dry yeast fermentation 1 week with rubber plug. Fermented mixture, separation of yeast via filtration. Filtrate containing ethanol plus water. Distillation 3 to 4 zeolites. Collect 80 to 90% milliliter distillate. Transfer to 100 milliliter volumetric flask. Which part? The 80 to 90 milliliter distillate to the volumetric flask? The density measurement, that's involved in section 1 too, right? Just a minute. Okay, gang, it's 6:20. I have the class at 7, so I think I have to just, get ready and get to class. I hope everything turns out well. It should turn out well, or it's not gonna turn out well. Well, peace, gang. I'm gonna record when I'm back from classes because I have a lot to plan. Peace.